But I think it might have sent in a JPEG.
We'll see.
Okay.
We'll see, and we'll have to. Yeah, we'll see.
And if
okay.
it does, is it considered
we'll
late?
we'll just figure it out. I mean, nothing's late. If it just doesn't go through, it doesn't go through.
Okay.
But let's just not worry about that right now. Let's get back into the fun stuff.
Okay.
I don't want Blackboard to occupy like 20% of the class talking about it. So anyway, back to our data from yesterday, or 2 days ago. And it was very boring. I have more interesting data to play with today. That's what this is boring. But the point of yesterday wasn't that it was the type of data that we had, but what we were able to get from the data. So here were the number of keys we were playing with in class. And we were able to calculate averages, medians, and modes from all of those things. What was the average number of keys we had?
3.1.
3.1? 3.4? 4.1? There we go. 4.1? Getting some nods on 4.1. What does that mean? On average, we had 4.1 keys per student. What does that mean? That's the mean. What does the mean mean? That's clever, huh? What does it mean to have an average of 4.1 keys per student?
You were to take all the keys and divide them.
Ah, it becomes the mistake I made earlier talking about voting, right? I said everybody should have an equal vote. No, you should have proportional vote. Well, the average says no, everybody should have an equal number of keys. So if we took all of the keys, pulled our resources into one pot, and then split it up evenly, it's how much each of you would have. So this person with 0 keys would borrow some from that person with 12. And actually, that person with 12 would actually lend out to a couple people, wouldn't they? Because they'd have to have about 4. So they'd negate that 0 and that 0. The next 12 would negate that 0 and some of these 1s. And eventually, it would all be 4.1, 4.1, 4.1, 4.1, 4.1. Is that fair? That's a loaded question. Is that fair?
Yes.
Yes? Is that fair? No, it depends on the context, really, if you think about it, right? It depends on the context, and part of today is answering when is the context fair and when is it not fair. So that's part of today. I mean, you have the tool now. Now it's time to know like when to use it. You've walked into a shop with all these beautiful glimmering tools. Well, there's like 3 tools right now. We'll develop more as we go. But it's like, which one am I grabbing for now for this particular application? So we'll get to there. So average is the sharing element. Good. What was our median? I think I can tell by looking at the data list what the median was.
Middle,
It was 3, right?
So 1835.
Yeah, it was 3. Good, good, good. See, and I hear the word middle. Candace, I hear the word middle. Talk about what middle. Middle of what?
all of your data.
In what way? How is that different than the average? Because 4.1 sounds like a middle to me.
Position of the data.
Ah, position. So Linda, if it's just position, what doesn't it care about? Yeah, the position doesn't care about the actual size of the value. And the extreme case, I think I made this case yesterday with you guys, was suppose this 12 was actually 120. Would that change the average, the mean average? It would, wouldn't it? Would it change the median? No, because the median doesn't care about the size of the actual data value, just its position, as Candace said. Yeah, very good. How about the mode? I think this was the first one you guys came up with together as a class. I think I could be wrong about that.
It was 3.
It was 3. And Sandra, what is the mode? I mean, in general, not for this data set, but
It's the most frequent.
it's the one that shows up the most, right? Shows up the most. Beautiful. Absolutely beautiful. And then I took this beautiful list of data away from you and replaced it with this. And said, let's recalculate all 3 measures. You said, why would we do that? Actually, you didn't say that. You're probably thinking it, though. We just did it. Why would we do it again? And my retort to that was what? Do you remember why I made you do it with this? Because I'm simply a bastard. Tell me your name again. Chrissy. That's right. Go.
To show that you don't need the exact numbers.
Yes, you don't need the exact numbers to get close. Well said. Also, very often, you're not going to get the exact numbers. You're going to get something like this. And it'd be nice to be able to pull some information from this, something useful from this. Seriously, thank you. So, how close did we get? What was our mode? What mode did we get from this?
4.
We did, didn't we? Now, there was some discussion about whether we should call the mode 3 to 5 or just 4. They're both fine, but from a computational point of view, you want to call it just 4. Why did we pick the mode 4? Because it's the tallest bar, and 4 is in the middle of that. I want to come back to that momentarily, but good, 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 good. What was the median? I bet you it's 4 too, isn't it?
4.
Yeah. Remember how we did that with the chopping of the bars? Yeah, but I can tell that this bar is about equal to these 3 bars combined. So if you chop all those off, that's chopping the top half of the data off, the top part of the data off. If you chop this, that's chopping the bottom part, and everything left is in the middle here. So the middle has to be 4. Now we know it's somewhere between 3 and 5, but as precise as you can get with this data, you can always call it 4. The slightly trickier one, right, was the average. And we're gonna continue that discussion today because I want to. But before, do you remember how we calculated the average in this case? How were we able to do it? Sandra, help me out.
We grouped all of the cluster points
Beautiful.
and added them together.
Yes, ma'am. Absolutely. So 0 to 2, we assumed everybody in here had 1, and there were 10 of them, so that's 10 keys total. Everybody in here had 4, and there were 17 of them. So 17 times the 4 gives us 56, I think, keys total. 7 times 5 is 35 more keys added into the pot. 1, 10, so 10 more keys added into the pot. And then it looks like 13 times 2 or 26 more keys added into the pot. We added up all those pot values and then divided by 35, I remember correctly. And wasn't it surprising how close we came?
Yeah.
Even though we were off probably in every single one of those bars, we were off a little bit up and a little bit down, a little bit up, a little bit down, and it kind of washes at the end and you get pretty darn close, which is pretty slick. Now, as I left Tuesday, I had the feeling you guys weren't entirely satisfied with that. So, I started building something that you might buy this, you might not, we'll see. I built what's called a Monte Carlo simulation. Let me shut this guy down for a second, start him back up again.